Let's get started with Solidity, which is a smart contract programming language for Ethereum virtual machine. We are going to start with program first and then see what are further details we need to study to further develop some other programs. That's what we are going to follow. So basically, we need an integrated development environment that could understand Solidity code and help you debug it and run it in a local environment. We need a Solidity ID first, then we will need some sample Solidity code. Obviously, I will be providing that, and you just need some time just to understand how the program works. So in order to understand a program, these are the basics you should first require. So things like what is a transaction, what is a externally owned account, and what all things are saved on a blockchain as part of a transaction or as part of a Solidity code that you need to understand. And you should also need to understand how to decode the various aspects of a transaction. So we can use a tool like Etherscan, or you can just see the transaction logs generated on the integrated development environment. So either way, Etherscan is a good starting point. For all this, I recommend this study material, which is a bootcamp course hosted by Alchemy. Copy this link and put it in your browser. So once you paste this link in your favorite browser, you'll be taken to this section where there's a course named Ethereum Developer Bootcamp, which is free of course. You can enroll for that. So basically, they will ask you to create Alchemy University account, and then you can get started with this course. Once you are in this course, we will be first seeing the relevant portions which will help us to go along with Solidity programming. So we can start with chapter 3, where there is some data about Ethereum transactions. We need to see that first. So what is the concept of a transaction and how does it affect Ethereum as a blockchain? That is clearly given in this chapter. So a transaction will cause a state change in the Ethereum blockchain. That is from sigma t to sigma t plus 1, it will cause a change. So a transaction may not be actually taken alone. It could be bundled along with other transactions in a particular sequence. So these transactions could be part of a block. And once a block is finalized, we can assume that, or we can visualize that block actually takes Ethereum virtual machine or the Ethereum blockchain from sigma t state to sigma t plus 1. So how will you visualize a state? All the states will be linked to some identifier. Okay. So if you are considering the state of a user, it will be addressable through a user's address or a public address. If you are considering the state of a smart contract, which are logic programs, they are actually linked to smart contract addresses. So if you consider here a human is shown, so this is an external actor. Okay, so for human beings, there is an account that is protected by a private key. That account is known as externally owned account. So human-owned accounts are known as externally owned accounts. So the major fields that are saved on the blockchain as part of this account are nonce and balances. So balance stands for the ether or token balances you have with you. So that is actually linked with your address and stored in the blockchain. Then nonce is actually the count of the next transaction that you are about to initiate. It is actually your account characterized by nonce and balance. So that is actually your account state, and it is kept track of using your address. Then what about a smart contract? Externally owned address, you will be actually deploying a smart contract. Okay, so your smart contract will have some other state more than your normal account because it is supposed to be maintaining its state over various transactions. So apart from nonce and balance, a smart contract account can have storage hash and code hash. So what is storage hash? Storage hash is actually the hash of the root of a trie that actually keeps track of the state variables of the smart contract. So what are state variables that we will see in our code example? So for the time being, assume that state variables are the variables inside a smart contract. Then what is code hash? Code hash is actually the hash of the root of a trie that actually stores the code of the smart contract. These are the two main things we need to understand while we do Solidity programming. So for a smart contract, apart from nonce and balance, there will be state variables as well as code which are stored on the blockchain. So every node on the blockchain will store the state variables as well as code of your smart contract. So your smart contract is actually replicated across all the full nodes of the Ethereum network. So that's actually millions of nodes. And when you actually do an action, or when somebody initiates a function call or a state variable change on your smart contract, it is actually reflected across all the millions of full nodes on the Ethereum network or all the nodes of the Ethereum network will execute that smart contract with the same input. So that's the main thing we need to understand. Now, in this lesson, they have also shown how addresses for smart contracts as well as addresses for your externally owned account is generated. So as I told you, if you are a human being, you will be actually creating a private key through some software mechanism. Then that private key will be used to generate a public key, and then hash of the public key is taken, and from that your public address or your Ethereum account address is derived. Then a smart contract can't be deployed on its own. A particular externally owned account should initiate a smart contract deployment. So that particular account which initiated a contract deployment, that is known as a sender address. So suppose that the account on the left initiated the deployment of the smart contract on the right. So the address on the left, right, this red colored address is the sender address, and the current nonce of this externally owned account is taken here, and it is used to generate the address of the smart contract. So what does it mean? So even if you deploy the same logic again and again from your externally owned account, the nonce value will keep on changing, right? So the address generated for your individual deployments will be different, even though the code will be same. So no two smart contracts will have the same addresses. It is ensured using such a mechanism. What happens during contract creation? Suppose that this is the Ethereum virtual machine or the Ethereum blockchain state before the creation of a smart contract. So there are some addresses along with account states. When a smart contract is created, an address for it will be allotted, and its state information should also be kept track of in the blockchain. So that's what is shown here. So for this address, and which is a smart contract address, apart from this normal account state, that is the nonce and the balance, code and storage, that is the state variable storage, will be kept track of. Now, in order to further understand smart contract and Solidity programming, we need to also know what are the details associated with the transaction. So just go to Etherscan. The link will be provided in the comment section. So just go to Etherscan and just click on any of the transaction details available. So if you see here, the transaction hashes will be displayed. So you can click on any of the hashes to know what constitutes the transaction. Okay, so when you click on a transaction hash, many details will be there. The primary detail you should know is who initiated the transaction, that is given in the from field. So here it is actually an Ethereum address mapped to Ethereum naming service. So if we just hover your mouse over here, the corresponding Ethereum public address is shown. Then to whom was this transaction sent? So that address is also shown here. So it is actually a smart contract. So DeFi smart contract to that this transaction was sent. Then what is the value of the transaction that is shown here? So this much amount of ether was actually passed to this this smart contract. So just click. We will just see whether it was a smart contract or it was a EOA. So when I clicked on the to contract address, it is showing me that it is a smart contract. Okay, so as I told you, a smart contract will be having balance value, and apart from that, it will be having storage of state variables as well as code. So if you click on this contract section, you can actually see the code that is actually stored in the Ethereum blockchain. Actually, it will be in the form of a trie. Okay, so you can just go through that. Then as I told you, there will be state variables also. Let's see the right contract section. If you click on the right contract section, you can actually see the various functions, smart contract functions which you can call. Okay, so actually the state variables may not be exposed because it depends on the access specifiers. Okay, we will get to that. So we are back to this page. So we understood what is meant by from field and to field. Then the value of the transaction, that also we understood. Then the transaction fee and the gas price, that you can actually, that's actually the cost required to do this transaction, right? So this was the gas price, so 19.48 GUI, and this is the total transaction fee paid. So that you can arrive at from here. Okay, so this is actually the gas used by the transaction, and the gas fee was here. If you multiply it, you will get this transaction fee. So it means that if it is a particular operation that causes change in the Ethereum virtual machine, right, it will actually incur some transaction fee. Okay, so here the transaction fee is actually less than $1. Okay, so these are the main things that you can understand from Etherscan if you get a transaction hash. So when we actually develop a smart contract in Solidity IDE, actually we will debug the code in its local virtual machine. For each transaction over there, a transaction hash will be generated, and if we actually explore that hash within the IDE, we will get all these details. All right, so we will just get to that.